everybody, welcome to our next session. Nice packed house. So yeah, you're all being a real treat. Just real quick, just to let y'all know, this is going to be a hybrid event. So meaning that while y'all are joining us all in person, we will have people virtually joining us too. So if you want to go in and join in on the conversations, the questions, just go ahead and scan those QR codes to the left and right of y'all. If you also want to talk to some of our experts, they will be upstairs on level 5 in the expert hub. We also have some amazing device demos and other things that are up there cool, so like that are up there that are so cool too. All right, no, not enough coffee. So let's go ahead and let's get started. So
awesome, thanks so much. Can y'all hear me back there? Yep, good, awesome. All right, well, good morning. And welcome to Infuse Your .NET Apps with AI, Practical Tools and Techniques. I am Luis, and I am a product manager on the .NET team working on AI. And with me I have Steven and Vin joining me. Steven, would you like to introduce yourself?
Yeah, I'm a developer on the .NET team, focusing on all of our libraries, performance, and for the last year or so, infusing AI into your .NET applications. So I'm glad you're all here.
Awesome, and Vin?
Yep, my name is Vin Kamat. I'm a principal architect at H&R Block. I do help build our tax systems, tax engine in the last couple of years, also generative AI.
Sweet.
Glad to be here.
Awesome. All right, well, thank you all for being here. I thank all the folks that are online watching as well. So good morning, good afternoon, and good evening to you all. So today, what are we going to be talking to you about? Well, there's going to be a ton of demos, right? It's going to be a technical talk, not highly technical. That's later today. Steven's going to be doing that one. But we're going to be showing you here how you can easily build applications using .NET and add AI to your applications, using the libraries, using the tools, and using the languages that you're already productive in, right? So for example, using libraries like semantic kernel make it super easy for you to go ahead and build these applications, and Steven's going to show us a little bit of that. And so regardless of whether it's a console app or a cloud native app, right, .NET makes it super easy for you to build these types of applications. When you're ready to go to production, you have tools and frameworks like Aspire, right, that allow you to build these types of applications, and they allow you to orchestrate your services that you're going to need in terms of talking to AI and all of these different services. You can also leverage Aspire for the dashboard and observe your applications and monitor them in real time. You can also leverage tools like AZD when you're ready to go to production, and when you're in the cloud, you can use the tools and services that allow you to monitor those applications in real time in production. And after that, we're going to have Vin talk to us about the lessons learned and some of the things that they've done to build applications using .NET and AI. So with that, I'm going to hand it off to Steven, who's going to show us how to build apps.
Awesome. Thanks, Luis. Good morning, everyone. I'm trying to get limber here because I'm going to just be typing for about 20 minutes. So bear with me. You've probably seen a bunch of talks over the last few days that have used AI in .NET applications in one way, shape, or form. Many of the ones that I've seen, though, have sort of just touched on it, or you've seen a little screenshot or a little bit of snippet here. We're going to go from 0 or one-line console.write line to just writing out all the code to see exactly what it takes to do the basic stuff of incorporating AI into your applications. Now, to do that, I'm going to use a library called semantic kernel, or a set of libraries called semantic kernel, which you may have heard of. It provides abstractions for talking to services like chat completion, or text to images, or audio to text, and then a whole bunch of implementations of those abstractions for talking with OpenAI and Azure OpenAI and Mistral AI and Google's Gemini and Vertex and Hugging Face and local models, whatever you might want, so that you can easily plug and play with them and experiment with them in your applications, or switch between them. Maybe talk to the OpenAI for a part of your application and a local model for another part of your application. And then it provides a whole bunch of helpers sitting on top of that and integrated with that to make it a first-class citizen as part of your .NET application. So that's what I'm going to use here. To get started with it, we need a kernel. A kernel in semantic kernel is just this tiny little object that you pass around that contains all of your services, like chat completion or whatever, as well as functions that the AI is able to orchestrate. So I was going to say kernel. Now, in a little bit, we'll see another way to create one. But to get started, I'm just going to say kernel.createBuilder.build. This gives me one. And then in the middle here, I can add in some services. You can see if I say add, there's a whole bunch of stuff that shows up here. For starting out, I'm just going to use OpenAI chat completion. We'll use GPT-3.5 Turbo. I could also use GPT-4o or whatever. And then I'm going to just grab from an environment variable my API key for OpenAI. Thank you, Copilot. And this is just because this is linked to my credit card, and I love you all, but I don't want you using it. We're going to have a little while loop here just to do a basic chat. I'm going to print out a queue for a question, so we'll say queue, and then print out the answer that I get back, console.writeLine, await, and I just say kernel invoke prompt async, and we'll just take whatever was provided by the user, aka me, on the console. And we can run that. Now I've been told that there are some networking issues, so we'll see if I can actually talk to OpenAI, but I can say hello. Ah, great, it works. My name is Steven. Nice to meet you too. What's my name? No idea. And that's because these models have zero memory. They're stateless. So I just made a request, got a response, and from its perspective, it was done with me. Now, if I actually want to have a conversation, I need to keep that state around. So I'm going to actually, rather than just using this invoke prompt async, I'm going to actually ask for a chat service from the kernel, which is one of the things that I added in. So I can say get required service, iChat completion service. And whatever services I put in here, could have been OpenAI, could have been Mistral, could have been Gemini, I'm going to get one of those, right? You can have multiple registered. There are ways to choose between them. But for now, we're going to keep it simple. I also want a chat history to keep track of all this stuff. And then I'm going to change this just a little bit. So I'll say chat.add user message with console.readline. That sounds good. And then I'm going to get a response back from calling chat, what do they call it? Chat service. Get chat contents, blah, 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 chat. And I'll print out the response, write line R. And I will also add that response into my chat history. We'll try that again. So now I can say, hello, my name is Steven. What's my name? And now it knows, because we were able to provide that history back to it. Of course, if I ask something else like, how old am I? Of course, it doesn't know. Now, maybe if I had added my last name, Toub, maybe something on the internet ended up in its model that would have told it how old I am, which is years old. But here we're going to actually provide it. So let me create a class called demographics. And I'll add a function here called getPersonAge. And we'll say return name, switch. And if it's Steven, yeah, sure, let's go with 30. That sounds good. I like you, Copilot. Now, where did that go? Thank you. Now, I'm going to mark this function as one that I would like the AI to be able to use. And really, all that's going on under the covers is when we're going to import this class, this object, into my kernel and allow it to invoke functionality. And I'm just telling it which functions I want to allow it to use. So I'll come up here and I'll say kernel.import plugin from type demographics, which is now basically just doing the exact same thing as if I had said kernel plugin factory dot create from type, which is just creating a kernel plugin object, which is the representation of something that contains functions that are just delegates and metadata associated with them. And then I could also just add this to the kernel directly by saying plugins.add. So this first line up here is just shorthand for that. Now that I have done that import, I also need some settings to tell the system, hey, it's OK to allow the AI to invoke this. So I'm going to say OpenAI prompt execution settings, and I'm going to say tool call behavior. You can do this automatically. So tool call behavior dot auto invoke kernel functions. And now the last thing I need to do is just go down here and pass in both those settings and the kernel that contains that functionality. And assuming I've typed things correctly, I can say my name is Steven. How old am I? Yes, I am. No, I'm not, but that's fine. And now, if we want to see what's actually taking place behind the covers, we can take advantage of the fact that, as I mentioned, these libraries are just fully integrated with the rest of the .NET ecosystem. So let me just separate out this builder into, I'm not used to typing on a laptop keyboard. Builder, and we'll have var builder equals this. And in doing that, now I can just access builder.services. And this is an arbitrary iService collection into which I can add all of the services you're used to adding with dependency injection in .NET. Anything from Microsoft.extensions or wherever that you're used to using from ASP.NET and MAUI and so on. So for example, I could say add logging, right? And I can import dependency injection, and then I could say add console, and I could set minimum level, log level, trace, all the stuff you're used to doing. This code is not specific to semantic kernel, but it will impact what semantic kernel is doing. So anytime semantic kernel goes to log something now, it'll take advantage of that logging. You can already see it showing up. We imported one kernel function. And now if I say, my name is Stephen, how old am I? There's a whole bunch of tracing that shows up. But the really interesting thing is here, we see that we made one request involving this many tokens. And the response wasn't the answer, you're 30 years old. It was a tool request asking me to invoke this function, demographics get person age, with the argument Stephen. We went ahead and invoked it because we were told that was OK. Using the argument name Stephen, it succeeded. It returned a result of 30. That went back to the AI. You can see there was another whole round trip here. And then we got back the answer from the AI. So you can actually see how that interaction is happening. The AI doesn't have access to my computer, but it's asking me to invoke things, and semantic kernel is automating that loop. And there's a whole bunch of ways that you can control that and interact with that. Now, these plugins can be anything. And if you look at the options that were available when I said let's just do kernel.import, you can see I can import from functions, arbitrary C# code that I wrote, or an object like I was just using if I have an explicit implementation of an object, or from a type, or if I have an open API specification sitting out there on the internet somewhere, I can create these from a prompt. If I have a prompt sitting on my disk, I can import that and use that. And there are plugins built into semantic kernel for things like doing web searches. So I could say kernel.import plugin from object, new web search engine plugin. IntelliSense is getting in my way. Engine, if I can type, engine plugin. Import that. And then we're going to use a Bing connector. So we're going to talk with Bing. Yes, that is my key. And now I can say, what sessions is Stephen Toub giving at Build 2024? You can see it went off and did a web search, and it says, apparently that's the name of the session I'm giving. Didn't know that, but OK. You can see it went off and it did this search with Bing for Stephen Toub Build 2024 sessions. And so I can easily compose all this stuff together. And again, this will allow me to do anything that I can do with any other service with dependency injection. So I could come in here and I could say, configure HTTP client defaults, which has nothing to do with semantic kernel, but it will be picked up by semantic kernel. I could say add standard resilience handler, nothing to do with semantic kernel, but this will automatically then inject into semantic kernel things like automatic retries, respecting retry timeouts. I could say, you know what, I'm on stage. I know that add standard resilience handler is going to show a whole bunch of logging that will include the authorization header that has my OpenAI key. So I'm going to ask to redact the authorization header so that all of you lovely people can't use my credit card. And then also builder.services.add redaction. And I can just do something simple like hello. And now you see a whole bunch of tracing coming out. Nothing to do with semantic kernel again, but taking advantage of it. You can see it's using poly for automatic retries. You can see there was an authorization header, which redaction redacted. All this stuff just fits together really nicely. And when it comes to dependency injection, there are other things that I can then inject. For example, if I wanted to further limit what these functions could do, I'm going to add a permission filter, which is a function invocation filter. Semantic kernel has these idea of filters that you can plug in and change how prompts are rendered, change how this auto invocation works, figure out what happens when I'm doing function invocations. So I'm going to automatically implement this, say implement interface. And I'll just have it do a basic thing of calling the next, what was it, context? The next filter in the pipeline or the eventual function. If I just write it like this, nothing is different. But now by doing this, I can do stuff before the function is invoked and after the function is invoked. So I could say console.writeLine, console.writeLine, allow, type. Oh, I hit the insert button. Allow, and then context.function.name, and let's also give it context.arguments. Well, let's leave off the arguments for now. Doesn't matter. Allow this to be invoked, and then I can say if console.readline equals yes. Actually do the next thing. Otherwise, let's just throw an exception and say permission denied. Sounds good. And now all I need to do is inject this permission filter. And a really easy way to do that, I could come up here and I could add it directly to my kernel. Or I could just, again, take advantage of DI integration and say builder.services.add singleton. I have a function invocation filter, and I've got my permission filter. And now when this goes to invoke something, who is Stephen Toub, you can see it got a function call request, and now it's asking me if I want to allow the search, just by putting that into my container. So I can do all my setup stuff over here, and the rest of my application logic doesn't need to change at all, because it's all just integrating nicely with DI. And this integration is, I mentioned earlier, this is one way of creating a kernel. But the more common way when you're beyond getting started and you're incorporating this into your ASP.NET applications or your MAUI applications is to just use whatever dependency injection container is already set up for you as part of the larger application. So here I just did file, new project, minimal ASP.NET minimal APIs, and I deleted a few things just to clean it up a little bit. But I can incorporate AI directly into the sample application. So if I run this, what this application is doing is generating a random temperature and then choosing a random description of what that temperature is. So I'd like to generate a random temperature, but use AI to describe the current weather based on what that temperature is. So I'm going to come up here, and I'm going to say builder.services.add kernel. And in doing so, now I can request a kernel from the dependency injection container. And I can add other services like builder.services.add. Let me do using semantic kernel. I can do builder.services.add OpenAI chat completion. Let me just actually grab it from over here, make it easier. So I don't have to type that whole thing out again. And now, down here, I can just ask for a kernel. And this kernel will be completely configured by dependency injection. We'll be taking advantage of ASP.NET's ability to just fetch this out of the container and use it. Let me put this temperature into a variable. So I can just say int temp equals that. And we'll put temp here. And then instead of this random summary that's being chosen from this fixed list, I'll do the exact same thing we saw earlier. I'll just say await kernel, invoke prompt async, short description of the weather at, sure, that sounds good. And I can get rid of these summaries. And this looks good. I should be able to run this. So I can run this. And now you see temperature 12 degrees, describing what that looks like. If I refresh, I get a different temperature, and I get a different description, and so on. And this can work not just with OpenAI, but with any service that I decided to inject. So I could come up here, and I could say, you know what, instead of OpenAI, I want to use Mistral. So I'm going to use Mistral chat completion. This is talking to the Mistral AI service. So I could say Mistral, what is it, small latest, I think is the name of one of their models. And then I also need to change my API key to Mistral AI. Again, linked to my credit card. And this one works too, with a slightly different kind of way of formatting the description, but still talking to an AI service. And so you can see with basically minimal code, I'm able to start with a console app, start with an ASP.NET application, and easily get this kind of AI logic into my application. I'm just scratching the surface of what you can do here. You can do stuff with custom prompts. And you saw on stage yesterday or the day before Prompty. You can easily load up Prompty as one of these kernel functions, which can then be used either invoked directly or automatically invoked by AI. You can do these amazing things end to end by taking advantage of these libraries that are already available for you today. And I hope you will. And with that, I will hand it off back to Luis.
Awesome. All right, that was cool. Now we know Steven's magic power here, Copilot. Let's see here. All right, so we saw that application working in a console application using semantic kernel inside of an minimal ASP.NET Web API. But now let's see it in the context of eShop, which you probably have seen many times throughout the conference here. And so If you haven't seen eShop, let me just kind of show you what it is. It's basically this e-commerce application where you have products and you also have this AI assistant here on the sidebar. Right? And so essentially what I want to do here is I want to just ask it a question. I want to ask, do you have any I don't know, watches for running? And then what happens here is it is going to go off. It's going to call the AI model, and it's going to come back with a response, right? Great. Now, as Steven showed, because this just works inside of your .NET applications, again, with the tools, the libraries, and everything that you're used to using today, and maybe including Aspire, right? You're able to see that with Aspire, we get additional functionality in here, right? And so in here, you're seeing the Aspire dashboard, and you have all of the resources that are available to you as part of this application. Now, we have a web app, which is the front end that you saw here, but we also have additional functionality here, like the catalog DB, as well as other services and dependencies here, right? And so we're able to kind of see this, this information here, but one of the really cool things is if we go back to sort of Visual Studio and see what did it take to basically compose this application. So one of the things that we're doing here is we are using OpenAI, and specifically, we're using the OpenAI Aspire component. And what that's going to do is, in the case where I already have an existing resource, I can just add my connection string, and that will work perfectly fine. But if I don't have a resource, and I want to go ahead and deploy a resource, I can also use that the hosting and the provisioning functionality inside of Aspire to say, hey, I want you to give me an OpenAI resource, and I also want to deploy several models to it, right? Once I have defined this resource and configured it, I can then just go ahead and reference it inside of my applications. And you'll notice that it's referenced both in the catalog API, as well as the web app, right, which is the front end that we just saw, the powering that AI assistant, right? Some additional functionality that you're able to get in Aspire is tracing and observability, right? So if we go ahead and check out the traces for this application, and we try to find, for example, this one, chat completion, chat 2, this is that interaction that you saw where I asked the chat assistant for running watches. And you can see that we get the full trace through our application. We noticed that we went through our web application. It invoked the catalog APIs. And then it used the information from the catalog API to return a human-readable response to me. Now, if we dig a little bit deeper into what this telemetry also provides us with, just kind of make this a little bit bigger. Sorry, 2 seconds here. OK. So if we look at this and take a look in more detail, let me kind of zoom in, might be a little bit hard to see, is you can see that I'm also getting information about temperature and top P, as well as the tokens that were used during this individual request. Now, what's actually powering this are semantic conventions for AI. It's currently a draft standard out of the OpenTelemetry organization. And it's still very experimental, but it's already built into semantic kernel. And because it's building on top of OpenTelemetry, and Aspire knows OpenTelemetry, you can just surface this to your application, right? Now, as the specification continues to evolve and it continues to develop, in .NET, you can be ensured that as a developer, you will have the latest features and whatever any new additions come once it is sort of accepted as a final standard, right? So other information that you're also able to get here is, in addition to information about the token counts, you can also see that you get information about the prompt. Oops, let me kind of make this a little bit smaller here. So you also get information about the prompts, right? And so you can see this is the role, the system in this case, as well as the content that was sent over to sort of in the chat history, right? And so, OK, great. So let's go back here. And so now that we are ready to go to production, right? One of the things that we can do here is we can go ahead and just invoke AZD up. Now, if you've seen the other Aspire sessions, you probably heard about the integration between AZD and Aspire and how easy it makes it to deploy applications. And in this case, by only invoking AZD up, I was able to take my Aspire application and deploy it into Azure. You can see that these are all the services that were deployed for me. And if I go back here to Azure, right, this is what it would end up looking like inside there, right? And you can see that I have Redis, I have my web app, which is my front end, which I can then access inside of Northern Mountains, inside of Azure here, right? So if we go here to the application, which is now running inside of Azure, you can see it's no longer on localhost. It's running up here. We can do the same thing, right? And so we can go ahead and invoke the chat assistant and ask it, do you have any watches for running? Or I think that's what I asked it last time. And it's going to go and do the same thing. Now, the really cool thing here is that because it is building on top of OpenTelemetry and these open standards, we can also use services inside of Azure to also monitor our application, right? And so if we kind of go to App Insights here, which is one of the resources that we provision, you can see that you are then able to get the traces and all this information about your requests that were made to the AI model. Kind of pull this up here. You can see that you have the same information. You have the prompt tokens, you have the reason for stopping. You could also inspect the prompts here. If you can see, it shows some more. You can see there's that there. And you can also get information about the completions, right? So regardless of whether you're building and debugging locally, you can get that real-time observability with Aspire. And as you go to the cloud and you deploy to your application to the cloud, you can also get that same rich functionality and observability in real time in Azure. So if we go back to the code here real quick, what did it take for me to go and add all this functionality for observing my application? It actually wasn't not a lot of code, right? So if we go over to the web app here, and we take a look at what was needed to get this running, effectively, all we needed to do was add this line of code. So this is, again, using that dependency injection. It's adding OpenTelemetry, and I'm specifically telling it, hey, I want to listen to any events that are coming out of semantic kernel. And it automatically populated all of the data that you saw in that dashboard, right? How did I get this set up with Azure Monitor or App Insights, you might ask? So if we go over here to our service defaults, let me just kind of find out real quick here. If we go over to our service defaults, you can see that if we go here to where we configure our telemetry, this is all that you needed to add, right? So you tell it builder services add OpenTelemetry, specifically use Azure Monitor, and this will start populating all that information that you saw locally inside of Azure Monitor, right? Okay, so how do you test these things, right? So as developers, we're used to writing unit tests to test these things, right? And so if we take a look here in our Test Explorer, you can see that there's a bunch of tests that we have available to us. And in this case, we are taking a question. In this case, we are asking about Python. Now, remember, this is an e-commerce application. But so you would expect that it wouldn't really know anything about Python programming or anything like that, because it is strictly focused to work with, to work in the e-commerce context. And we can see that once the the response came back, it said, I apologize, I couldn't find information, as we would expect. But you're going to see that there's this relevance of 1, right? Now, relevance, in this case, we're just measuring, again, like the name sort of implies, how relevant is the response to the questions that was asked by the user. Now, what exactly is powering this experience? Let me kind of show you what the tests look like for this. Let me drop this down here for a second. OK, so we have a project here, unit test. And basically, it's just using XUnit, right? So you might be already used to this. This is probably how you're writing unit tests today. And if we take a look here at how we're testing this application, 1 second here, we are just creating this theory, right? We have this test, ask common questions, returning coherent results. We have a bunch of services that we're mocking. We're filling up our catalog with a bunch of information, right? And then we're also using this helper function here called relevance eval. Now, relevance eval, all this really is a plugin, right? And this plugin contains a prompt, which then gets sent to the AI, and you basically ask it, hey, given the question that was asked and given the response that was returned, how relevant is it? And what you get out of that is a score that tells you the relevance of that. In this case, it's between 1 to 5. If we take a look at the relevance here, you have escape prompt, and it's essentially just a prompt that's being sent to the LLM, and that's what effectively is sort of returning what that evaluation is. But in the context of setting up these tests, right, it's the same test that you would write for your application, right? There's not much difference there, and semantic kernel is making it easier for you to make those requests and get those responses from the model and those evaluation metrics. All right, so that's it. In the meantime, I will sort of hand it off to Vin here, who's going to talk to us about how they are putting applications into production and deploying them using .NET.
Hey everyone, so I don't have demos, but I do have some slides and sharing our journey. Okay, so we started our journey pretty early. So we had a prototype built in March of 2023, and by December we had a bunch of things that we did, and some of them we shipped to production. So on the top you see we shipped the AI tax assist. we have this mentality of move fast to learn fast. So that's what we are attempting to do here. And there were so many unknowns when you start on a journey like this, especially with generative AI and its non-deterministic nature, tools and things that are already not mature enough, but they're rapidly evolving. So we embrace semantic kernel, for example, early on to start to grow along with the library itself. And our apps that we built have also evolved, just like semantic kernel. So there are some internal apps that also we built. One of them was private and secure enterprise ChatGPT before Copilot or enterprise ChatGPT by OpenAI was available. And we also built multiple RAG apps using different content data sets to learn how does content impact the quality of the responses. I'll focus a little bit on the AI Tax Assist. You can use it if you go to H&R Block online and start a new tax return and get some help. So the goal here is to go from lookup-based user interfaces, like we have almost like a search engine. You have to sift through a bunch of results and figure out what you want. We also had a virtual assistant, the old-style chatbot experience. From there, we went to a very natural, human-like back and forth happening. So this is pretty simple, right? Like there's not a lot going on there, but the goal was to figure out how to build these kinds of apps. And one of the things that we did is to start with our tech stack. So the application is built using .NET 7 and C#, and all these things, right? We use Azure Functions, SignalR Hub, OpenAI SDK, obviously. We use the Presidio SDK for PII anonymization. Again, a fantastic library to use. Cosmos DB, Azure Storage. We also use Blazor server app for internal tool sets. Looks a lot, but you have to start somewhere. And from an infrastructure standpoint, we use all these services, long list. Don't worry about it, because here we have a very high-level conceptual architecture. So there are two parts to this. On the right-hand side, you see the design time, what happens. For example, all the content sources, we have a content ingestion pipeline using Azure DevOps, where we suck in all that content, store it in Azure Blob Storage. We have Azure AI Search, semantic re-ranker, hybrid indexer. So there's lots of stuff going on here. But the key here is on the design time, you build up this vector index that you're then using in runtime as the queries come in from the application UI. And in the center, we have our compute workload, which is basically running on app service environment. And we run the semantic kernel code there, in-memory records, right? Because back then, that's what we started with. We have query and retrieval, persistent telemetry using Cosmos DB, Azure SignalR service, which is managed. We also use the managed PTU. You must have heard about the managed PTU deployment model with Azure OpenAI up there. And we also use the ADA embedding model. So most importantly, what did we learn in this journey? And we're just getting started. So this is a long journey, and we want to learn stuff really, really fast. One of the things that we learn early on is don't sweat the small stuff. So early on, when we started using these APIs and starting to learn about temperature, top P, frequency penalty, stops, all that stuff, it's easy to get lost in that world and figure out how it works. So just pick the most optimal default configuration that you have and just go with it. That's something that we learned. And time for evaluation and testing is way longer than development. So you can have an application get developed and ready for testing pretty quickly, as you saw from the earlier demos. But what comes after is the hard part. Like, how do we get that going from 80% accuracy to 100% accuracy? And that's where you have to learn. And the sooner you get into this mode of learning and improving, the faster you'll make progress. The next big thing that we learned is reports and data, right? So because reports and data are really important for you to evaluate, and you need to have, they call it MOMO model monitoring. I'll quickly go through this list, but pick a leading model. There's lots of models out there. What's more important is how you build your solution. UI and UX, obviously, very, very important. I like to say UI makes AI work, just like from ChatGPT. Think human-like assistants. This is another thing. We're not building a chatbot V2. We want it to be very human-like so that there are no breakdowns in interactions between the user and the assistant. Obviously, you have to test internally first before you go live. Some of the insights is prompt engineering. It sounds like it's easy, but it's really hard when you want to go attack that last 20%. So spend a lot more time on prompt engineering. It seems simple, but trust me, it's harder. And the more steerable the LLM is, the more sensitivity is to your prompts. So one of the latest model, like the GPT-4 0409, for example, is very steerable. It's awesome. Like you can pretty much use it like a programming language, like you're basically writing a program. You have variables and structures and all that stuff. But yeah, we have to be very careful with the prompts. Level of comfort with uncertainty is really required because it's non-deterministic nature. So be comfortable with uncomfortableness, and then fine-tuning. Just start with prompt engineering first before you go to fine-tuning. So we have a few things that we have lined up for what next. One of the key ones here is personalization, which is obviously very important when you have an application like this. But we also want to improve seamless tax expert handoff, so there is no breakdown there, and then also improved human and automated evaluation testing. So all these things are, we're really looking forward to it and excited about it. We'd love to answer questions after the session and share more what I've learned. Thank you.
All right, thank you, Vin. That was awesome. Okay, so we are about to almost close off. I think we'll have a few minutes for questions here as well. I just want to make sure, it is the last day, so a lot of these sessions have actually happened already, but make sure to check out the recordings. There's a lot of really great stuff, a lot of .NET content there that you're going to want to check out. Also, if you haven't heard, we are excited to share that this is the official, the upcoming preview for the official OpenAI client library for .NET developers. So this was built in partnership with OpenAI. This is going to support all the latest features that come to OpenAI, such as Assistance v2 or GPT-4o on day one, right? So it's going to be releasing in the next few weeks. And so you want to make sure that you sign up for the link that's sort of up there. Make sure to sort of give your feedback, effectively just, give us feedback as to how, we can grow this library. There's also a ton of resources. The team has been working really hard on .NET resources and content for you to sort of get started with AI. Please fill out the survey. Help us build the future of .NET and AI. There's the link up there. And this is just the beginning, right? So join us for .NET Conf. We got a ton of stuff to share with you come in November. That's the official .NET 9 launch. And yeah, just join us there. So in the meantime, I'll just shift on over to questions and answers, and yeah, take some either online or in the room if there's any.
No questions? Yes. So the question was, the demo that I showed was sort of turn-based. I do something, the AI does something, I do something, the AI response comes back. The APIs for doing the sort of streaming constant interaction haven't been made available for 4.0 yet, but it will be something that you'll be able to do. Great question. So the question was, what's the difference between the OpenAI library and semantic kernel? So semantic kernel layers on top of whatever client library might be available for the target service in order to provide an implementation of and integrate with its abstraction. So you may have seen as it scrolled by in the long list of tracing that was output to the screen, but one of the headers talked about what library was being used. When I was talking to OpenAI, that was sitting on top of the OpenAI library. Semantic kernel just wraps it to implement it for its interface. There are such wrappings for Gemini with Google, for Mistral. In cases where there isn't a client library, it's just using HTTP client directly. In cases where there is, it's using that library and constantly staying up to date with it. Where possible, they're in the box, but these are just abstractions that can be implemented by anyone. So if you go and search for NuGet, you'll find other implementations of these provided by whomever on top of those underlying libraries. Yeah. Yes, sir. Mm-hmm. So the question was, in the example that we showed, I was giving it some function to invoke. Could I just point it to a table in a database? I assume you mean for sort of retrieval augmented generation. Absolutely. There are multiple ways to do RAG, one of which could be directly, I just implement a function that queries my database for the request that came in and sends back the results. So you can write a little bit of code to do that. You can also take advantage of pre-created such plugins by other people to do the exact same thing. Although for a database, there's probably customization you have with your schemas and so on. But this is where vector stores come into play in particular. And I didn't show, I mentioned there's a whole bunch of stuff I didn't show. Semantic kernel has abstractions for memory stores and implementations for not only all the popular vector databases like Chroma and Weaviate and Pinecone and Milvus and Quadrant and whatever, but also more traditional databases like SQL Server or DuckDB or Postgres or whatever, plus cloud-based services like Azure AI Search. And so you can also integrate in that fashion with plugins that come in the box where you just say, hey, I want a search plugin for this vector store. Here you go, AI, you're able to use it. And it's about the following thing, and it'll be automatically selected.
So real quick, there's one online, on question online, so let's make sure we answer that one. And I think it was for Vin, right, the question?
I think it was for me.
Yep. What was the question?
The question was, did we use fine-tuning and LoRa? And the answer is no.
Right.
Easy.
Very quick.
Short and sweet, love it. Right there in the light shirt.
Yeah. Yeah, great. Right, great question. The question was, how did we verify that the responses were good? And one of the things that we did early on when there was no prompt flow, nothing, we built our own domain-specific testing tool set, which is basically setting up evaluation pipelines. You must have heard about these tests that Luis was showing, like relevance, coherence. So you got to come up with all these metrics, evaluation metrics. The latest one that we used is the usefulness and helpfulness that we are experimenting with. So basically, you want to make sure that it's all driven by prompts, though. So you're using higher frontier models to test, and your actual application may be using a regular 3.5 turbo model. So you have to use higher intelligence to kind of run those evaluation flow pipelines. But also, we do a lot of human testing. So we use these testing tools that we built in-house, of course, on the same stack that you saw out there. And we make sure that the scores are really high and we're comfortable with them.
We have time for Brian, one more question here.
Question about the plugins. I know you define one method, assuming like if you have a ton of different plugins, different methods that you call certain page, whatever. Does that mean that when you make a request to the OpenAI, for example, you pass it the list of those methods, and it figures out which one to use?
That's a great question. The question was, we were creating a plugin. It contains a bunch of functions. Does that mean when I make the request to the service, are those functions somehow described to that service as part of the request? And the answer is absolutely. That's exactly what happens. If you were to look at what gets traced out, what's sent out on the wire, basically, when that object got imported into the kernel, it created this kernel plugin with these kernel function objects, each of which was some code that could be executed, as well as metadata around it. What is the function? What is the name? What are the parameters? What are their types? We basically auto-generate JSON schema to describe all the types, or the OpenAPI specification, if that's what you were importing, would have JSON schema to describe all the arguments. Anything that is in that kernel object that you then pass in and say, here, this is available to you, will then be described automatically, if you ask it to the AI. So all those functions get sent, and then the AI reasons about it and either answers, provides a chat response for what you asked, or says, you know what, instead, here are the 3 functions I'd like you to invoke. Please send me back the responses. There's yet another turn of the crank where you make a request, it sends back its request to you, you do all your evaluation, you put those back into a brand new request and send it back, and Semantic Kernel is just automating that for you. Thank you.
All right, thank you all for attending. We will be up in the 5th floor at the experts area if you have additional questions, so join us there. And yeah, thank you for coming.
Thanks a lot.
Thank you.
On the dot.